Okay, welcome. Last lesson for business math. Yay. Okay, 7.4 is our permutations and combinations. So the first thing we want to do is locate the exclamation mark symbol on your calculator. So on the regular TI-30, it should just be under probability right here, PRB. There it is, right? On the graphing calculator, you have to go to, what is it, math, and then all the way over to probability, and there you go. There's the exclamation mark. Okay, so this is the first thing we want to try in the paper is what is 5, oh, and by the way, that exclamation mark is actually called the factorial symbol. So we want to look for the values of 5 factorial, 0 factorial, 30 factorial, and 75 factorial. So all I have to do is hit 5, and then go to math, go to probability, and hit enter on the factorial button. Enter, and you get 120. So there we go. That'll get us started. Okay, and then 0 factorial, same thing. You get 1. Okay. And then 30 factorial. We get, oh, a very big number. I'll say 2.65 times 10 to the 32nd. And then 75 factorial. We break our calculator. So, overflow error. Meaning the number's just way too big. Okay, so that's factorial. All right. What does it mean? Okay, so a collection of n different items can be arranged in order n factorial different ways. The factorial rule reflects the fact that the first item may be selected in n different ways, and the second item may be selected in n minus 1 ways. So n factorial is also known as n times n minus 1 times n minus 2 times n minus 3, all the way till you get to 1. Okay, so all we want to do here is figure out what 1 factorial all the way to 10 factorial is. All right. So we can type them in all separately in our calculator, or I could do this. I go to my table and I say y equals x, and then go to math and type in that x factorial. Then it goes second to table, we're on ask and graph. All right, this will make it faster. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So down below, I get 1, 2, 6, 24, 120, 720, 5,040, 40,320, 36,200, 362,880, and then this would be 362,000, not actually 3 million. Right, that's the 6 decimals. 1, 2, 3, 4, 5, 6. Yeah. 3,628,880. Okay. So all the factorial does, if I wrote it above, let's look at 6 factorial. 6 factorial would mean 6 times 5 times 4 times 3 times 2 times 1. Just like the above, minus 1 and minus 1 and minus 1 to give us 720. Okay, so that's how factorials work. It's kind of like the combination lock that we did on 7.3, which was you had to make a 3-digit combo with no replacements. So you got 10 choices for the first one, and then you got 9 choices for the second digit, and then you got 8 choices for the third digit. So imagine if you had to make a 10-digit combo where none of them could repeat. That would be 10 factorial, which means if you had to make a 10-digit combo where the numbers could not repeat, you would have to make, you would have 3,628,880 possible choices on how to make your lock. Okay. There we go. Okay. So, example 1, I will randomly select students one at a time without replacement until all students have been selected. How many possible orderings if I have 3 students? Well, that would be 3 factorial. So we're not replacing the students, right? We pick one, and then we choose another one, and then we choose another one. So that would be 3 factorial, which from above is 6. And then B, how many possible orderings are if I have 5 students? That would be 5 factorial, which from the above chart is 120 possible orderings. And then C, how many possible orderings are they if I have 24 students? That would be 24 factorial, which we don't have, so I will calculate 24 factorial. Oh boy, that would be 6.20 times 10 to the 23rd. So that would be the possible orderings if you were randomly selecting 24 students without replacement. Okay, awesome. So that is how factorial works. All right, lots of reading on the next page. Factorials are used to find the number of ways all items in a population can be ordered when selected one at a time. For example, if you have 5 items numbered 1 through 5, you can select them in the following ways. And we make this humongous table of all the ways you can order the numbers 1 through 5, and the ways you can rewrite the numbers 1 through 5. Well, after we make this whole table, we figure out that there are 120 possible ways to rewrite 5 items. Okay, well, we also know that this is equivalent to 5 factorial. And 5 factorial is 5 times 4 times 3 times 1, which is 120. So factorial makes it way easier to calculate how many ways we can order a population when selected one at a time. Okay, awesome. So would you want to make a table, or would you rather use factorial? Okay. Next is the definition of permutations. Permutations are used to find the number of ways a sample of items in a population can be ordered. The keyword here is ordered when selected one at a time. For example, if you have 5 items numbered 1 through 5, you can select 3 items in the following ways. 6 rows times 10 columns, you get 60, right? Okay, so there are 60 possible ways to order, 5 items. So if you have 5 items numbered 1 through 5, you can select 3 items in the following ways. So there's 60 ways to do that. And the way we sum that up so we don't have to make a chart is we use the permutation button on our calculator, which I'll show you how to do. So what we say first is the total amount of items. So we have 5 items, and we want to permutate or pick 3 items. So we'll go math, we'll go probability, and we're going to hit NPR. So 5 pick or permutate 3. So 5 items, and we want to pick 3 items in order, which gives us 60, which we have down below. So this is if ordered matters. So permutations all rely on order, okay? They rely on order. Next up is combinations. Combinations do not care about order. Combinations are all about chaos. So again, we're going to deal with the 5 items numbered 1 through 5, and we want to select them in 3 ways, but we don't care how it's ordered. So this means that we ignore the order, and each column in the table above contains repeated drawings. If you have 5 items numbered 1 through 5, and you select 3 items in the table above, since the order of selection does not matter, we collapse the table into a smaller table, right? So it becomes a 1-row table with 10 columns. And if you ignore order, then if you have 5 items and you want to select 3 items in the following ways, there will be 10 ways to choose from if you ignore order, right? If we go out of order, we don't care the order. So to show that, we again say 5, and you go to probability, combinations. So 5, choose 3 still, right? Or 5, combination 3. No order, and you get 10. So if you ignore order, there are 10 ways to pick, 5 items numbered, numbered 1 through 5, right? 3 different ways. Ugh, did that make sense? Probably not. All right, so if you ignore order, you can select 3 items numbered 1 through 5, 10 ways. There you go. Probably still sounds terrible. Okay, this is why we saved this lesson for last. Okay, so all we want to do is practice on our calculator, finding out how to type these in. 5 permutate 3, 12 permutate 8, 5 combination 3, 12 combination 8. All right, so let's do it. I'll show it in another calculator too. So I would say 5 probability pick 3, which is 60. $12 permutate 8, which is 19,958,400. And then 5 combination 3, you get 10. And 12 combination 8, 495. 495. Okay, so that's how we type them in our calculator. And what is the main difference between permutations and combinations? The main difference is the word order. Permutations deal with order, combinations don't care about order. So that is the main difference, is order. All right. Oh my goodness, look at that last page. All right. All right, for these questions, we want to know, does order matter? If order matters, we use a permutation. If order does not matter, we use a combination. All right. And we can apply the multiplication principle we learned in 7.3. All right, example 3. In a long distance foot race, how many different finishes among the first 5 places possible if 50 are running. Now you have to ask, is there order or no order in a race? If there's no order, everyone can finish first place, even if you're last place. Now, does that make sense? No. It'd be nice, but no. So there has to be order in a race. There's only one person who comes in first place, right? So this would be a permutation. So this has order. This is a permutation. And to do this permutation, well, we're going to do, we know there are 50 people running. So 50, but we are only allowed to pick 5 places. So we'll have 50 pick or permutate 5. And there are, what is that? Oh, 254,251,200 possible ways for people to come in the first 5 places. Hey, that's not a bad way to say you have a chance. What's this? 37, pick 5, or 37, choose 5. Yeah, it's better. Okay. To win the jackpot in the Texas Lottery's Cash 5, a player must match all 5 numbers drawn from a field of 37. How many possible outcomes are there? Is there order or no order in the lottery? And I believe that there is no order. The numbers fall however they want, and all you have to do is match them to the numbers on your paper. So there is no order. So this would be a combination. Meaning that you have 37 numbers to choose from, and you must match all 5 numbers. So that would be 37 combination 5. 37 combination 5. Which means you have a chance to win out of 435,000 possible ways for those numbers to fall. That's saying you have a chance, huh? Maybe you could be that 435,000 person. Okay. To win the jackpot in the Texas two-step, a player must match 4 numbers drawn from a field of 35 and match 1 number from a field of 35. How many possible outcomes are there? All right, once again, these numbers do not fall in order. So this is again a combination. But now we have 2 fields we have to pick from. So first, we have 35 numbers to pick from, and we're only allowed to combine 4 or choose 4, right? But then we also have 35 numbers to choose from, but we can only pick or choose 1. Let's see our chances. 35, pick 4, times 35, choose 1. And you have 1,000,000. you have a chance in 1,832,600 ways to win the lottery. Now, that's really a chance to win the lottery, huh? Oof. Okay. Awesome. All right. Number 6. 3 departments have 12, 15, 18 members respectively, so in order. If each department selects a delegate and an alternate to represent the department at a conference, how many ways can this be done? All right, so this one is definitely order because there's certain positions to fill, right? So we need a delegate and an alternate to represent the department at a conference. So this means that this is a permutation. And each department. So for the first department, we have 12 people, and we can only pick 2. For the second department, we have 15 people, and we can only pick 2. Again, a delegate and an alternate. And then for the second department, or the last department, we have 18, but again, we can only pick 2. And it has to be in order. It has to be a delegate and an alternate. That's order. Okay, let's find out what we have. 12 permutate 2 times 15 permutate 2 times 18 permutate 2. And the ways that all 3 departments can do this is out of 8, what do we have? 8,482,320 possible ways to pick an alternate and a delegate. Okay. Last one. Forever. All right, an electronics store receives a shipment of 30 graphing calculators, including 6 that are defective. 4 of these calculators are sent to a high school. How many selections can be made? All right, order or no order? So there is no order on this one. We are shipping calculators to a high school. There was no possible way to order the calculators we have chosen. We have just taken 30 calculators and shipped them to a school. That's it. So this would be a combination. All right. So this means that there are 30 calculators to choose from, and we can only pick 4. 4 of these calculators are sent to a high school. All right, so 30, choose 4. $30 combo 4. That is 27,405 ways for the school to get these 4 calculators out of 30. Okay. How many of these selections will contain no defective calculators? Well, if 6 calculators are defective, this means that 24 calculators actually work. And this means the 24 that get sent, well, the 24 that are not defective, 4 of them will get sent to a high school. And to figure out how those will get sent will be 10,626 possible ways to select no defective calculators. Okay, because again, there's no order. This computer company, this electronics store, doesn't know which ones are defective. They're just sticking their hands in, pulling out 4 calculators and sending them to school. So there's no order in that. Okay. And that is it, guys. That is 7.4 permutations and combinations. And we are done.